started? All right. I was in such a hurry I forgot to bring markers with me. Hopefully not. Hopefully we're good. All right. So, had a couple people with questions for today's labs. So, I will try to give you some pointers to be able to answer it. We're not going to be able to go through the entire simplex method, right? That would take the whole class period to do. So instead, what I'll do is I'll give you some key values for each iteration, so you can kind of see how you are doing and make sure that you are making progress. Shoot, most of you did not bring laptops, and I didn't send you an email to tell you to bring laptops today.
Did not.
All right. No, definitely are not going to cancel class, but it's going to make. You'll have to repeat what we do in class later on if you didn't bring your laptop. So we're not there yet. So let's start. So I didn't write down which problem this was. So for problem 18, 17, 18. That's confusing to say. Where you had the minimization of 84x1 plus 4x2 plus 30x3. What was the first transformation that you need to do to make sure that you were able to do this with the simplex method? Negate it and max. I heard both of those things and they were both right? We're going to treat this as if it's a maximization problem where we negate the whole thing. Right? So, and then we just follow our steps like we've done before with our maximization problems. All right? Then if we do our constraints here, I'll try to do this quickly here. Plus x2 plus 3x3. This is a less than or equal, so what kind of constraint, how are we going to transform this into standard form? Adding slack, right? So we add slack and we set that equal to 240, right? The next one, 16x1 plus x2 plus 7x3. This one is a greater than or equal constraint. So what do we need to add? Or subtract, I should say. A surplus. And you should just start to recognize immediately that all of the surplus values are immediately going to also have with them an artificial variable, right? Because the surplus variable is naturally going to be negative, and that's not going to work. So we're also going to have an artificial variable show up. Okay. And then finally, this is also a greater than or equal constraint. So it's going to look just like the last one. And then we're going to have x1, x2, x3, s1, s2, s3, a2, and a3 are all non-negative. All right. What is going to be our starting basis for the simplex method here? Which variables are we going to assume to be non-negative? S1, A2, and A3. Okay? And what are their initial values going to be? No, these values are the non-zero ones. Initially, all the other ones are 0. So if all the other ones are 0, we know that this is 0, this is 0, this is 0. So that means that S1 is the only variable left in our equation. So the value of S1 initially starts out as 240. Okay, what's the initial value of A2? 480. And what's the initial value of A3? 160. Now, I think a lot of you said 0 because you were thinking of this objective function, right? This objective function has 0 S1, 0 S2, 0 S3. And notice I close this off before I switch to the maximization problem. Minus MA2 minus MA3 here. All right, and so I think a lot of you saw these zeros here because you were thinking about when we do our simplex method, and you put in S1 at A2 and A3. You were thinking of these zeros, this 0 right here, but that's not the value of S1. That's the coefficient for the S1 value in the objective function. And they're different. Okay? So S1 starts off, we have to go all the way to the right-hand side of our simplex and look at it, and that's going to be our 240. That's what S1 starts out as. A2 starts out as 480, and A3 starts out as 160 right here. Okay, those are what our current guess is when we initially start off. S1, A2, and A3, and then the remainder of our guesses, X1 equals X2 equals X3 equals S2 equals S3 equals 0. Right? This is our initial starting condition for our simplex method. And each time we iterate, we're going to change one of these non-zero values for one of these 0 values, and we're going to reevaluate this objective function and try to get it larger and larger and larger until we can't any further. Yes?
Can you remind me how we decide which variables to set to 0?
Well, because we don't know a good value for our starting variables, we're just going to start them out as 0. And then that naturally leaves the slack variables as being non-zero, because that's the only variable left in our equation then. We would like to have had our surplus variables be non-zero as well, but they ended up being negative. So instead of having our surplus variables be non-zero, we also let our surplus variables start out as 0 and give the non-zero value to our artificial variables instead. So in our starting simplex, it's always going to be our slack variables and our artificial variables in place of our surplus variables. Those are going to be our non-zero variables. There will be one for each equation. All right. So now here's where I go into fast forward mode. All right. And I'll give you what the basis variables should have been for each iteration. Okay, so after this first iteration, you should have replaced the A3 variable with the X1 variable. So your new basis should have been S1, A2, and X1. Okay, that should have been your next iteration that you went through. After that, you should have replaced the slack variable with X2. So it should have been X2, A2, and X1. Okay, and I know the temptation to go from here to here is say, well, we don't like these artificial variables. Of course it has to be the artificial variable that drops out. But it doesn't always work that way. Okay, I'm sorry. After that, the next variable that drops out even more might be surprising, is we're going to drop out this x1 for x3. Okay? So this artificial variable is a weak variable, and it's not until this last iteration here that we get rid of our artificial variable in this solution with a surplus variable of 3. And the solution should have been x2 equals 60, s3 is 20, and x3 is 60. One additional area that may have been confusing because it was in your reading, but I didn't explicitly say it in lecture, is what to do if over here you got some value like negative 523. Because that is smaller than 17 or 92. Okay? We don't pick this one, even though negative 523 is smaller, because it's negative. Okay? It's invalid to consider it. We have to only consider positive values. All right? And I didn't explicitly say that in lecture, so I'm sorry if that caused you to go off the rails, so to speak, in the solution here. Yes.
Is that only true for like the right-hand side?
Yes, it's only true for the right-hand side. We ignore these negative values and only pick the smallest positive value. Yeah. Again, when we look at the values here, again, we're looking at the largest positive value. So then negatives are smaller anyway. So it didn't matter in that account. Mm-hmm. Yes?
Is it also possible or okay if you end up dividing by 0 and get an undefined number?
Yeah, so if you end up dividing by 0, it's an undefined value, and just ignore that row as well. Yeah, that's an even worse degenerate case, yes. Which also happened, I think, in your next problem, right? All right. So go ahead and look through your solution. Again, you're not being graded if you got exactly 60, 20, 60. It's that you took each step along the way. But if you did not get 60, 20, 60, you should evaluate why not. Was it an arithmetic error way up here? Was it that you did the wrong process? Those two are very different. If you did the wrong process, I want you to do it again. Either do it with me or do it with another student that understands. Don't stop until you understand how the process is supposed to work. Okay? If it is an arithmetic error and you can identify what that arithmetic error is, now you have to evaluate, is it worth repeating this with the right arithmetic operations, or did you understand the process and get it right? That's a lot harder for me to clearly identify, yes, you should do this again. Because that wasn't because you didn't know what you were supposed to do, you just accidentally did the wrong thing. And you accidentally said 3 plus 2 is -1 or something like that because you got the wrong sign or something like that. And that's something that I want you to look through for this problem and evaluate how to proceed here. All right? Make sure you understand how the steps of the simplex method work, because for the upcoming test, you will be given simplex problems to solve. It may be that I ask you to set up a simplex problem, or I might give one that's halfway through and you have to get the next iteration done. Or I've got numbers in here and you have to tell me what the next basis is going to be and why that is going to be the next basis. Right? You need to be able to do all parts of the simplex. What is not feasible in a time frame of a test is to go through all of these steps and then do all the other stuff that I'm going to ask you to test. So you're going to have to be able to understand all those parts and be ready to demonstrate any one of those parts, but I'm not going to ask you to demonstrate all of those parts all at once for a particular exam question, if that makes sense. Yes?
What else is going to be on the test other than simplex and stuff?
So you're going to have to be, I'll go into this in more detail as we get closer, but you're going to have to be able to do a graphical solution of a problem. Okay? And you're going to have to, so that means you're going to have to be able to draw lines, show the intersection of lines. You're going to have to do sensitivity analysis, so understand the range of the coefficients. You're going to have to be able to understand the dual. And what we're going to be doing between now and the test is really looking into more detail in the sensitivity analysis, because we're going to switch to letting the computer do these solutions for us. And the computer is going to give us the dual directly. And the computer is going to give us the range of the coefficients directly. So we're not going to have to continue to compute those. So now what we're going to do when we switch over to computer solving the problems, rather than us manually solving the problems, is interpretation of these solutions and understanding, well, what if this changes? So think about the first example that we did with the homework assignment was the manufacturing plant, where we asked, should they buy 500 pounds more of steel? We're going to start asking those types of questions, and we're going to be using the sensitivity analysis to help us make those kinds of decision-making processes. And so in those cases, I will probably give you an entire model, and I will already run it through the computer for you, and I will give you the output from the computer, and it's going to be not can you solve this problem, but can you interpret the computer solution that's given to you. Yes?
That's going to be on our test
Yeah.
next Thursday?
Next
Or
Wednesday.
next Wednesday.
Yeah. Yes. So that's what we have in store for us to get ready for. All right? So let's go ahead and pull out your laptops if you brought it. I need to log in here myself. All right. No, I want someone else. And what is my password here?
Oh, renew.
I've been putting it off for like 6 months, so I haven't updated my. I don't have any.
All right. So if I've never logged into this computer before, so it's going to take a little bit for it to set up my profile. All right. So what I would like you to do is that one. Okay, it's on. Is open up your web browser and go to a site called OpenSolver. OpenSolver.org specifically. Okay? And you should come up with something like this. what we're going to do is when we install OpenSolver, it's going to add this set of menu options to our ribbon under the data tab. Okay? And so what we're going to be able to do is input our model, and we're going to have it be able to solve our model directly. Okay? And so we want to be able to install this. Now, OpenSolver supports Excel only, well, and sort of Google Sheets. It implies it does, but it doesn't work very well. And it's better run from Windows machines than Mac, but I was able to get most students last year who had Macs without a problem running it. Okay? And there are separate install instructions for a Mac than there are for Windows. One of the things that I'm going to have the computer science seniors working on this January for their senior project is porting this project to the LibreOffice suite so that you can use a different spreadsheet that maybe doesn't cost you as much money as Microsoft Office does. But that's not available right now. So if you go ahead and choose the download install option, you can go ahead and see that there are different instructions for macOS than there are for Windows. Okay? So make sure if you have a Mac, that you follow those properly. So I'm going to download the OpenSolver package, and I'm going to save this file. My download. All right? And then I am going to go temporarily to my desktop. And I'm going to create where is it? Oh, it's that. Oh, I know what the problem is. Fine. Desktop. I'm going to create a new folder. I guess I'm not creating a new folder. This might be interesting. I never used the campus domain. I might be working really hard over the next couple days before we meet back together. All right. That's not what I wanted. Where is... So let's just extract this. Sure. I would extract this somewhere where you know where this is going. So if downloads works for you, great. It wouldn't work for me. I would put it somewhere else, but this is not for me. Okay, so now this is the extracted file right here. What I'm going to do now is I'm going to open up Excel. Blank workbook is fine. And I'm going to go to File, Options. And I'm going to pick this Add-ins option right here because we're adding in this OpenSolver tool. All right? Let me pause. How many people need me to wait before you get this far? Okay.
Where's options?
Probably Command comma.
Yeah,
This is not the same. This is not the same install for the Mac. So you definitely need to follow the install instructions for a Mac, which are lower down on the page. Okay? Here's what I'm going to do. I'm going to go through this once myself, and then I'm going to walk around and try to help people who are having trouble, so that those who are keeping up are also good. So after I get to the add-ins here, I'm going to go to Manage Excel Add-ins and click on Go. And I'm going to pick this Browse option here, because notice that OpenSolver isn't in here right now. And what I'm going to do then is go to this file that I extracted from that zip file, and I'm going to click on this OpenSolver thing right here. Now notice when I do that, this OpenSolver shows up. And what this should now do is if I click on the Data tab, we have our OpenSolver tab available here. Last thing I'm going to do here is I'm going to click on OpenSolver. And I'm going to click on this About OpenSolver right here. And I'm going to make sure that this is checked down here, where it says Load OpenSolver when Excel starts. What? I clicked this and then About OpenSolver right here. And I double check that this is clicked. And the reason why I'm doing that is now I don't have to do this ever again. Okay? So now what I'm going to do is I'm going to exit out of Excel to double check that this has been installed permanently for me. And I go to the Data tab. And it didn't show that. So check something real quick. Options, add-ins.
Okay. So it's
Okay. So this is what you should show up. Now, I've not chased down exactly what happened here, but the second time I opened Excel, it didn't show these for me. And so what I did is I just went back to the add-ins option and I turned the OpenSolver off, and it goes away, but it was already away. So then I just turned it back on because OpenSolver was in this checkbox. And that's all I had to do to get it show again. So if it's not showing, that's a quick way to do it. It's supposed to, this checkbox is supposed to do that. So I don't know why it didn't. All right. So I'm going to walk around now. If you've got questions, I can try to help answer them. Yeah. Yeah, there wasn't original. But one thing you can do is you can just try and close this and you try to OpenSolver file around, and that might install. I've already done. Probably $100. Okay, sir. And you gave it your.
I never got that. Well, I mean, right now I'm trying to.
I didn't get go back over there are some macros.
Let me see if I can just. Which version?
Yeah, so to make sure that. So
If only. So now it's actually.
what I would say is we can try to define it offline. Right, saying.
And I might be able to.
Yeah, and that's not a big problem. Yeah. It looks like it's installed. Yep, you can see that.
Did you do
Yeah, we don't want to use that. It does the same thing, but it's not a good. So did you follow the Mac instructions? Okay, yeah, uncheck the solver. And did you go through all the Mac install? Like, did you click on the package that you were supposed to do for the Mac? Did you run the Mac? Yeah, right. So there's different installers. Go back. There were different installs.
I think we're supposed to store it.
Scroll up some. Sorry, down. Keep going. And you want to follow these instructions.
How do you know
I'd be surprised if you had.
Mine came up, mine told me to go to Microsoft Office.
Oh, so you have no numbers.
And then in Office and in add-ins.
I don't even have that full.
Oh, there it is.
I don't think you guys have Office 16 or 11.
Yeah.
You have one of those.
It's there.
Yeah.
Oh my goodness.
It's probably.
Oh, it was there the whole time. Well, I don't know. I just want
So yeah, follow those instructions. So you downloaded a zip file, right? You downloaded a file.
Yeah.
What did you do with that downloaded file? Inside the solver file. Now you have to check this file.
Yeah, I'm looking at the first one.
That's the first one. This is the second one.
Okay.
We should go through.
Oh, you probably have to Excel close. That's
We'll work on this after class. I'm going to fail this class.
Untrusted software that you download.
Oh, unless you do think that.
And run it without.
Okay. So let me show you how this works now. Okay? And what I'm going to do is I'm going to go through the next homework assignment that was due for today. We can see what the final solution was. So that was 1719, right? So step one for our word problems, what are you trying to do? What are you trying to figure out for that problem? For 1719, what's the objective of this company? Or not the objective. What are they trying to figure out? The right way to allocate boats, right? The workers were just going to naturally fall out of it, right? If I had this type of boat, I had to have this many workers for it, right? So how many variables does that necessitate then? Which are? Okay, so what was the first kind of boat? Sailboat, so let's call that S. And that's going to be the number of sailboats. If I can spell. Cabin cruisers. And yachts. All right, that's what we have to figure out. And if we figure that out, what are we trying to do? Maximize profit. And what are our constraints? Let's go to this table right here. Can you give me one of the constraints from problem 19?
So S plus B, or C plus Y equals 10.
Or is less than equal to 10, right? Because we don't have to have 10 captains. But that's the maximum we can do. Up here, what's another constraint that you had?
S plus 2C plus 3Y less than or equal to 18.
Right, so this represents the number of captains. What did that constraint that you just gave me represent? The number of crew. How about over here? Can you give me a third constraint?
S has to be less than or equal to 4.
What does that represent?
There has to be less than 4 or less sailboats.
Right, that's what we have. That's a physical constraint. We can't coordinate more boats than we actually have in our yard. What's another constraint? The back.
C is less than or equal to 8.
Right. And that's very similar, but instead of the sailboats, it's the cabin cruisers, right? And next to them, someone there.
Y is less than or equal to 3.
How about here? What is it? Say it louder, Josh. All right. That's the catch-all, right? You always get that for free, right? Right? And then step 4 is our objective function. What's our objective function? We want to maximize profit. How do we compute what our profit is?
plus 70C plus 100Y.
So let's put that into Excel. Okay? So we know our variables are number of sailboats, number of cabin cruisers, and number of yachts. And I would really encourage you to go and be verbose on here, because if you just put numbers in here and keep the text out, it's going to be really hard to understand what they represent. And our profit. So our profit is going to be, it's going to be 50 times B1, right? Because we get $50 for every sailboat. Plus 70 times B2 plus 100 times B3, right? We just take the amount of each one of these that we end up choosing to reserve times the profit for each one of those. So this cell is just going to automatically compute what that profit is. So if we decide to sail 1 sailboat, 2 cabin cruisers, and 4 yachts, even though I don't think that's legal, we would make $590 from doing so. Right? So this is what we've computed here. So then I'm going to put in our constraints. And I'm just going to do each one of these. So this constraint is B1 plus B2 plus B3, right? It's S plus C plus Y. Those values right there. And I'm just going to put, right now, that's equal to 7. Has to be less than or equal to 10. And I can repeat that now for this one. But now it's going to be S, which is B1, plus 2 times C, which is what? Where's the value of C? B2, plus 3 times, where's the value of Y? B3. And that has to be less than or equal to 18. And then these last 3 ones are going to be really easy, right? What's the value of S? B1. That's going to be less than or equal to 4. What's the value of C? B2. And that's going to be less than or equal to 8. And then, what's the value of Y? B3. And that's got to be less than or equal to 3. Okay, so now I have put in there, and I'll zoom it in. So, whoa, let's zoom it in. Right there. Now we're going to use OpenSolver to solve this for us. So I'm going to click on this model button right here. And you can see that it's got this set of panes, and we're just going to go top to bottom. So let's start with our objective cell. Here. The objective cell, what are we trying to do? We're trying to maximize profit. So I'm just going to click on this profit cell right there. Okay? And I need to make sure that I click on maximize so that we maximize profit rather than minimize profit. Right? Variable cells right here. These are the values that OpenSolver is trying to give for us. It's these values right here. So I'm just going to highlight these 3 values right there. Those are the variables that can change. And then we need to add our constraints. So here, our first constraint is that this value is less than or equal to this value right here. And I can add that constraint. And then I go again. This value is less than or equal to this value. And add that second constraint. This third one Yes, but I wanted to wait for that. Yes. So now I've got all 5 constraints in here. We've got our objective, our variables, our constraints. Since we're not going to look at it today, I'm going to not check these. But you can get that sensitivity analysis from here. The CBC is what we want, so we can go ahead and save that model. Now notice what it does right here. It gives it very clear what's going on. These are the values that are changing right here. This is what we're trying to maximize. And these are all the constraints. In fact, notice that it puts these less than or equals. So from now on, I'm not going to put less than or equals in here. Okay, because we know when we add the constraints, it's going to automatically put those in there for it. So it's very clear. The one thing I don't like about this is it's really hard to edit these numbers because it actually put a little graphical box on here and you kind of have to move it out of the way and then you can get it. So that's the one downside I think there is to this right here. All right. So now that we've entered our model, all we have to do is click this solve button. There we go. The answer should be that we do 4 sailboats, 4 cabin cruisers, and 2 yachts for a profit of $680.
What did I do wrong?
All right. So, this is the tool that we're going to continue to use throughout the rest of the class. So, after your exam, you don't have to worry about excuse me. You don't have to worry about trying to do the simplex method and if you're going to make those arithmetic mistakes. But if you don't understand how the simplex method works, you can set these models up in really, really bad ways. And so you need to understand how it works to make sure that you build viable models. So now that you understand how it works, we're going to let the computer do the grunt work, and we can do the thought-provoking work of how to construct these models and how to interpret the results that come from the solution, computer solutions to these models right here. Yes?
If you have an objective to minimize,
Yep.
do you go ahead and negate it and enter it as a maximization, or you enter it as a
No, it's smart enough to do that for you. So you can give it minimizations, and it will do the right thing for you. In this case, we can test it out. You should be able to guess what the minimization is going to be, right? Before I even pick solve, right?
Yeah.
What's the minimum profit going to be? Think about it.
Give away the vote.
Yeah. Right, so the closest we can get to that is that we don't do any boats, right? So it's going to be all zeros. All right? We will not have class on Friday because I'm going to be gone at a conference. So